Welcome to qnawire.
Okay, well, let's draw an alkane, ketone, and alcohol of roughly the same molecular weight. Let's do propanol. Okay, so if we're within 5 grams per mole, right? So if we're going to lose an oxygen, right, we're going to gain a CH3, right? We'll lose an OH, which weighs 17, and we'll gain a CH3, which weighs 15, right? So that seems fine, right? To go from uh, propanol to butane, right? And likewise, we can imagine propanal having a similar molecular weight, right? Here we've simply, in fact, propanal and propanol should have the exact same molecular weight. No, that'll be slightly different. Actually, it'll be two less. Okay, these are all within 5. That's the important part. Okay, so now let's consider how we would rank them in terms of boiling point. So I'm just clearing myself some space here. So the highest boiling point here, number 1, is going to be the alcohol, followed next by the propanol, followed finally by the alkane, right? So in terms of boiling point, the alcohol is the highest, then the aldehyde, and then the alkane. Okay. So we can do this with another set of compounds, as they ask. We can simply expand the chain by 1, right? There's no problem with that. Same idea, we would rank them 1, 2, and 3. Okay. So then what is the pattern that we can describe, which identifies the relative boiling points of alkanes, ketones, and alcohols of roughly equal molecular weight? Okay. And we could say alcohols have higher BPs than ketones, aldehydes, which have higher boiling points than alkanes when molecular weight is held roughly, we'll say plus or minus 5 grams per mole constant. Okay, and then that's the answer to question 5. For 6, what we're going to say is what are the intermolecular forces that explain this observation? And that has to do with hydrogen bonding, right? So notice alcohols are fully capable of hydrogen bonding with themselves because they contain both hydrogen bond acceptors, oxygens with lone pairs, as well as hydrogen bond donors, bonds between oxygen and hydrogen, right? This is our donor, and this is our acceptor. Right? Alkanes don't have any hydrogen bonding capabilities, and they're nonpolar. Okay. Aldehydes or ketones don't have hydrogen bonding abilities, but they are polar, right? Alcohols are also polar, of course. Anything capable of hydrogen bonding must be polar, right? So the reasoning here is alcohols have high boiling points because they have strong IMFs, that's intermolecular forces, due to polarity and H bonding, hydrogen bonding. Aldehydes and ketones have moderate IMFs due to polarity. Alkanes have low boiling points because they have weak IMFs because they are non